Buenos. Well, that's the way we say hello in Peru. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of physics. Now, children, I'm sure you people must have seen a rainbow in the skies when there is sunlight after rainfall. But have you ever seen a spectacle like this? No? I know. But make sure you see it before God takes you away. This is Vinicunco Mountain, Cusipata, Peru. It is 16,500 feet high, and here trekking is gonna be fun when you're with some special one. This rainbow mountain has mineralogical differences at the summit, and that is the reason why it looks so. Make sure to be here as soon as possible, and also to have the mouth-watering Peruvian purple desert Maza Mora Morada, and also to tell all the people of Peru that you get to meet Buenos. In this note, children, I'm going to start off this lecture on electric potential. Last time, you remember, we talked about current electricity, where when we talked about the passage of some charges in a conductor, that was known as current electricity. Now, before we come to the topic of electric potential, let us quickly look up what can be the meaning with regards to some other topics. Now, I'm sure you people must have seen that water does flow from a higher level to a lower level. For that matter, let's talk about a river which is flowing. So in a river, let's say there is a riverbed which is higher, and there is some riverbed which is low. That means the silt which is underneath the river's water. So where the silt is higher, that as a higher level, and where the silt or the riverbed is lower, the level is lower. So water always flows from a higher level to a lower level. Similarly, if there is a body which is hot and there is another body which is cold, and both of these are put in contact, the heat will flow from the body which is at a higher temperature to the body which is at a lower temperature. In physics, when we talk about electricity next, we now talk about, say, a conductor which is, say, charged, and another conductor which, say, is charged. Then when both of these are put in contact, then we define, like in normal language, the electric potential to be that state of a conductor such that the charges flow from one conductor to another conductor. Now, as we know that the positive charges cannot flow because they are stuffed too much within an atom, that is within the nucleus, as they have a very strong nuclear force with which they are attracted with the neutrons. That is why electrons are the ones which only flow, and thus whenever there is flow of charge in the external circuit, electrons are the ones which flow. And electrons will always flow from excess to deficiency. That means wherever there are more electrons, from there the electrons will flow to where there are less number of electrons. So as such, if we talk about the electric potential, it is the state of a conductor when the electrons will flow from excess to deficiency. And as the direction of the conventional current is from positive to negative, so obviously it will be from deficiency of electrons to an excess of electrons, right? So this, children, in the general language or in the common man's language, can be the definition of electric potential, and I'll quickly repeat it. Electric potential is the state of a conductor which tells you in what direction will be the flow of electrons, or in other words, what will be the flow of the charges. Now, if we talk about electric potential in accordance with a proper scientific definition, then, children, now we'll be talking about, say, a group of charges. And let's say now that we have a group of charges, say something like this, right? And this, say, spherical space which has been made, now let's say, is where there are some negative charges, right? And say this be a point where the electric potential due to this group of charges is to be found out. Now, electric potential is defined as the amount of work which has been done on a unit positive charge to be brought from infinity to this point near this group of charges, right? So this is how, children, we can define electric potential. And now for you people, I'll also write it, and along with me you also do write so that you can understand better. Electric potential. Here we will say the ratio of the work done in bringing an unit positive charge, that is, in brackets you will write plus 1.6 into 10 raised to the power minus 19 coulomb, as we looked up in the last lecture, that is the smallest amount of charge which is possible from infinity to a point. Now we'll name that point also, say A, near the group of charges is said to be the electric potential. At the point A, due to those group of charges, right? Now I'm sure when you've written this definition along with me, you are more clear. So I will quickly discuss once more. Let's say we have a group of some charges and we require to find out the electric potential at, say, a point A. Now in order to do so, what you do is you talk about the ratio of the work done in bringing a unit positive charge from infinity to this point A, right, to be divided by the magnitude of the charge. Then that will give you the electric potential. And this is further what I require to write. That is, now we'll be talking about to the magnitude of the charge. That means in the denominator we also have to keep the magnitude or the numerical value of the charge. Unit positive charge. And like I told you, this unit positive charge is how much? It is plus 1.6 into 10 raised to the power minus 19 coulomb, right? Now children, what is the formula of electric potential? Now electric potential is given by V is equal to W upon Q, where capital V is how we represent electric potential. That means this is the symbol which will represent electric potential. W obviously is the work done and Q obviously is the charge. So if you want to write the unit of electric potential, it is in the name of an Italian physicist, that is Alessandro Volta, and that's why we write the unit of it as small v, right, which represents this unit of electric potential in his name, right? And as you can see here, we have it as the unit of work, which is obviously joule, right, and it is going to be divided by coulomb, which is the unit of electric charge, right? So thus 1 volt is equal to 1 joule per coulomb. And if you want to write it in terms of SI units, you can write it as 1 kg meter square per second square, and that further is going to be divided by coulomb. And remember children that 1 coulomb is equal to 1 ampere second. So here we will write 1 ampere second, right? And as such, we can further write 1 volt to be equal to 1 kg, right, meter square, right, and per second cube ampere, which will actually become the perfect SI unit of electric potential. So here we talked about the general normal language definition of electric potential. After that, we talked about the definition in physics of electric potential. Then we talked about the unit of electric potential as a volt, and we further also talked about the SI unit of the electric potential. Now children, we'll talk about another term, which is potential difference. So what is potential difference? So if say there be 2 points, right, at which we talk about the potentials, right? So let's say now that we have 2 points at which we talk about the electric potential. Let's say there be a point A, and let's say there be another point B at which we have to talk about the potentials. And let's say the potential at the point A be VA and the potential at the point B be VB. And if we are to find out the potential difference, then the potential difference will be given by VB minus VA if we are finding out the potential difference of A with respect to B, right? And if suppose we are talking about the potential difference of B with respect to A, then we write it this way, right? So when we talk about the potential difference, it's actually the difference of the potentials of 2 points, right? Now, normally, whenever we talk about the potential of a specific point, the potential is higher for a positive charge and it is lower for a negative charge, right? So as such, when we talk about the flow of electrons, it will be flowing from that terminal which is lower in potential, because there will be an excess of electrons, and it will be flowing to a higher potential which has a deficiency of electrons. And when we talk about the direction of flow of conventional current, which is the direction of current as scientists thought, which actually does not have any reason, later it came to be known that only electrons can flow. So the direction of the conventional current will be from a higher potential to a lower potential, that is from a positive potential to a negative potential, right? So this is all that you require to remember, right? Next, now children, we will be talking about another thing, that is we talk about electric current, right? Remember children that when we talk about here in the last lecture, if you remember, we talked about the flow of charges to be current electricity. Now, this flow of charge from this positively charged rod to this neutral conductor is going to happen in infinitesimally small time. That means it will happen very, very, very fast, probably in microseconds, right? But we don't require current to be there for us for so small a time interval. Just think that here we are working in light, we are working in a computer system, we are using mobile, and we don't want it for a split of a second that light comes and goes. Then what will we be able to do? We won't be able to do much. So we require electric current for a sustained amount of time, for some good considerable amount of time. Now, in order to have that, children, we require to have a potential difference. So for that matter, always remember that if you require to have electric current for some sustained amount of time, for some good amount of time, there has to be some potential difference, right? So let's say if we talk about this VA, right, to be say at some positive potential, and say we talk about say VB to be at some negative potential, like we normally have in a cell, right? In a cell, which in times to come we'll be studying, we have electrodes, right? And these electrodes are one which is at a positive terminal, right? And there is another which is the negative terminal, and both of these are at a higher potential and a lower potential. And when that is kept due to the chemical reaction for a long period of time, thus due to this potential difference in the external circuit, we have electric current, or we have electricity, that is the flow of electrons, right? So remember children, in order to talk about electric current for a sustained amount of time, what do we require is we require potential difference. So this is again something which is very important, and that I'll write for you people, and along with me you also write. For electricity, that is electric current for sustained time, that means for some long time, a potential difference is required. Right? So whenever there is some potential difference which is created for some time, there will be the flow of electrons from excess to deficiency. And in the next lecture, we will be discussing about how in a cell we have the functioning, we have the different chemical reactions, we talk about the electrodes, we talk about the electrolyte, and we talk about joining the terminals by some conducting wire so that there is some passage of charges for some sustained amount of time, which gives us electricity, right? So all of these things that I told you people, I'll just quickly discuss once more so that everything is perfectly clear. The first thing that I told you people is that whenever we talk about an electric potential, you got to remember that electric potential is actually the state of a conductor, right, due to which there is a flow of charges when it is connected to another conductor. Normally, whenever we talk about the flow of charges, it will be the flow of electrons in the external circuit. That means in the wires through which current comes to us, right? Because electrons are the ones which can only flow. The protons cannot flow because they are tightly bound within the nucleus by nuclear forces with the neutrons, right? Now, when the charges flow, always remember the charges always flow from excess to deficiency, that is from excess of electrons to deficiency of electrons. But the direction of the conventional current is opposite to the direction of the electronic current, that is it flows from the positive terminal to the negative terminal, and the direction of the electronic current is from excess to deficiency, that is it is from the negative terminal to the positive terminal. The positive terminal is considered to be the higher potential, and the negative terminal is considered to be the lower potential. So the conventional current flows from higher potential to lower potential, and the electronic current flows from the lower potential to the higher potential, right? In a way, you can say that whenever we talk about electric potential, the flow of charges happen from a greater concentration of charges to a lesser concentration of charges. That re-explains again the movement of electrons from excess to deficiency. Further, children, we talked about the scientific definition of electric potential, which I'm sure is a little difficult to understand because this has some different terms which are new to you. That is, if suppose we talk about, say, there be some conductor which has some group of charges, probably some negative charges, and due to those group of charges at a specific point in the electric field of this group of charges, if you require to find out the electric potential, then that will be given by the ratio of the work done in bringing a unit positive charge, that is plus 1.6 into 10 raised to the power minus 19 coulomb of charge, from infinity to that point in the electric field of the group of charges, to be divided by the magnitude of this charge, that is with the numerical value, which is 1.6 into 10 raised to the power minus 19 coulomb, right? So here, children, we write it also by this formula, that is capital V, which is the electric potential, is equal to W upon Q, right? Now here we also talk about the unit of electric potential. The unit of electric potential is V, which is in the name of the Italian physicist Alessandro Volta, right? And here, children, as this is the ratio of joule to coulomb, so as such here we can write this to be 1 kg meter square per second square, which is the unit of joule, now which is to be divided by coulomb, right? And as the unit of coulomb that we studied in the last lecture is ampere second, so this is going to be divided by ampere second. As such, the unit of volt is going to be 1, I'm sorry, I made a mistake here, 1 kg, no, it's perfectly fine. It is 1 kg meter square per second cube into ampere, right? As this second square is also in the denominator, so as a second square into second is going to become second cube. Remember, for that matter, that if suppose we have, say, some A which is divided by B, and which is further divided by C upon D, then further this can be written as A upon B divided by C upon D, and in the next step you can write that to be A upon B into D upon C, right? This is how this 1 upon second square, right, will remain in the denominator and will get multiplied with second to become second cube, right? Okay, so this was the definition. Then I told you another very important thing, that is, how is it that we have some electric current, right, for a sustained period of time. So when we talk about electric current or current electricity, that happens just for an infinitesimally small period of time, like we talked about in this experiment when there was a charged conductor which was put in touch with an uncharged conductor. Now if we have to have current for a long period of time, like normally what we use for using computers, laptops, mobiles, or for say any other electrical equipment use, we require the electricity there with us. That means the current electricity for a long period of time, right? For that there's always a difference in potential which is required, right? So you require to remember that if you talk about a potential difference between two terminals, right, which is developed for a long period of time as it is done in cells, only then there will be a flow of current from excess of electrons, right, to deficiency of electrons, right? And as excess of electrons is where there will be negative terminal, which is considered to be the lower potential. So the electronic current will flow from the lower potential to the higher potential, and as the direction of electronic current is just the reverse of the conventional current, right, which is what scientists thought earlier because they did not know that the positive charges can't flow. So the direction of the conventional current will be from the higher potential to the lower potential, and in order to have this you require to have some potential difference between the terminals, so that for a sustained period of time there is electric current, which actually is known as electricity. So I'm sure all of this that I told you people is very well clear and you've understood what electric potential is. Our next lecture will make electricity more clear with you. Wait for that lecture, and till then, bye guys, have a nice time, do study all of this, bye.